Experts can't explain a signal scientists still can't decode. It was not discovered during a dramatic breakthrough. There was no announcement, no press conference, no warning that anything unusual was coming. The signal appeared quietly, detected by scientific instruments designed to notice very small changes. Changes that usually have ordinary explanations. At first, it looked like background noise, the kind researchers see every day. Random, messy, unimportant. But when the data was reviewed more closely, something stood out. The signal was brief. It didn't last long enough to study in real time. But it was structured. Not loud. Not continuous. Yet distinct enough to be separated from the noise around it. The first step was verification. Before asking what a signal means, scientists ask whether it exists at all. Equipment was checked. Calibration logs reviewed. Environmental interference considered. Loose cables. Power fluctuations. Software artifacts. None of those explanations fit cleanly. The data behaved consistently across the system. That didn't make it mysterious. It simply meant it was real. Next came comparison. Scientists compared the signal against known sources, natural phenomena, atmospheric effects, solar activity, cosmic background radiation. The signal did not match typical signatures. It didn't follow expected curves. It didn't decay the way similar signals usually do. Artificial sources were also considered. Satellites, aircraft systems, ground-based transmissions. Those possibilities were tested against time, direction, and frequency. Again, the match was poor. At this stage, nothing had been explained. But nothing extraordinary had been claimed either. This is where many stories usually end. An anomaly noted, filed away, forgotten. But this signal didn't disappear from discussion. Because when other teams looked at the data, they saw the same thing. Independent analyses were conducted. Different software. Different assumptions. Different processing techniques. The conclusions aligned. The signal was present. Its origin was unclear. That distinction matters. Science is comfortable with uncertainty, but it is careful about language. No one described the signal as a message. No one claimed intent. No official explanation was offered. Instead, the signal was classified, documented, stored, and compared against future data. One of the more puzzling aspects is its behavior. The signal does not repeat on a predictable schedule. It doesn't appear daily, weekly, or yearly. Patterns have been searched for. Some researchers see clustering. Others do not. What everyone agrees on is this: the data is incomplete. Because the signal was short, and because instruments were not originally focused on capturing it. That leaves open questions, but not conclusions. Over time, some explanations have been ruled out. Not because they were impossible, but because they failed repeated tests. Other explanations remain under consideration. not because they are preferred, but because they have not yet been disproven. This is often misunderstood. Unexplained does not mean extraordinary. It means the available data does not allow a confident answer. For now, the signal remains archived, stored alongside countless other anomalies. Some may be explained later. Some may never be. As instruments improve, as methods change, as comparisons expand, researchers may one day understand what this signal represents. Or they may simply understand why it cannot be decoded. For now, it exists as data, recorded, verified, and unresolved. Which theory makes sense?